Everyone, nice to be here, even if here is actually Munich, Germany, and I'm only joining you remotely as everybody this year. My talk is called The Three Pillars of Effective Digital Product Development. And I want to talk about how avoiding bad practices in digital product development and adapting better ones in three main areas will improve quality, velocity, predictability, and your team's motivation. Because the reality is that many projects and teams fail, at least every now and then. And I'm sure everyone here has experienced that for themselves. It would be nice to do a quick show of hands, but obviously, like in the setup, we can't, but next year we can again, hopefully. And failure comes in many forms. Like first, missing time and budget constraints is probably the most common kind of failure, where teams miss deadlines or spend more money on projects than was planned, or in the worst case, they run out of money midway, even before shipping anything. Also, shipping doesn't necessarily mean everyone is happy. Maybe users do not want what was delivered, as it is not, as it addresses not a problem that they actually have, or they just don't understand how to use what was delivered because it has a poor quality, poor usability, or quality is so bad that they can't actually use it because it breaks all the time. There's also organizational failure, where you could say teams and projects get stuck on a structural level, and there's no way to accelerate velocity or improve quality because you can't grow the team really, right? Or growing the team doesn't lead to more output. And then that often leads to people becoming demotivated, which can cause fluctuation among the team, which causes more demotivation, which causes more fluctuation and so on. And for all these problem areas, I don't say I have a magic spell and it makes all problems go away forever, but I do have some insights and advice I'll share in this talk. Most reasons for failure, as well as the respective solutions, lie in three main areas. First, planning and preparation, where many teams approach that with sort of the wrong level of detail for the different scopes they're dealing with in a project, resulting in over planning on a macro level and then under preparation on a micro level, which leads to unrealistic plans in the beginning and then even problems delivering on those plans. Second is process and collaboration. Many organizations still apply top-down management in an effort to ensure that teams deliver. The idea is that if you're not applying a bit of pressure and if you're not on people's back, they won't maybe don't do anything and you will not get any results. In our experience, that's almost always more harmful than it does good. And then last, infrastructure and practices, which is something that is very often overlooked. We see a lot of teams that are given a single hammer and then asked to build a skyscraper with that. And of course, that doesn't work. And we look at these three areas one by one. However, given I have relatively little time here, I'll be focusing on the last pillar and only touch on the first two relatively briefly, sharing only sort of the key points. So first, planning and preparation. These are important to get right tasks and they're easy to get wrong. But getting those wrong is particularly hurtful or harmful because the planning and preparation step sort of is where you raise expectations. And then you disappoint them if what you planned or prepared fails. And the main problem here in our experience is over-planning, where teams project what they will be doing or what they will deliver in too much detail too far in the future, right? While in reality, nobody can know any of that. It's all just made up, basically. When you say in 6 months, we deliver feature A, B, C, and then another 6 months later, we deliver feature D and E. It is often done in an effort to look extremely productive or engaged or ambitious. Ambitious is a term you will hear a lot in that context. But in reality, ambitious is sort of just cipher for unrealistic and thus essentially irrelevant. At the same time, while making these ambitious plans, teams would sort of under-prepare the work at a smaller scale, or sort of on a lower level of scope, so that they constantly start working on seemingly small tasks and then only understand the real nature of these tasks once the work has already started. And that real nature is typically that this task is bigger than it appears in first glance, leading to all kinds of inefficiencies, right? Where things get delayed and so on. So the answer to all that is generally to treat each scope you're dealing with at the appropriate level of detail, going from little level of detail to a high level of detail while the scope gets smaller. The entire project is too big of a scope to do anything with, really. Typically, you will only know what sort of the scope of all of your project was in hindsight when you've done it. So this is essentially irrelevant and nothing you need to care about. Like no 2-year plans, whatever. Nobody knows what you will end up with after 2 years. We recommend moving in 6-week steps, which we call increments, where each increment is like a coherent set of functionality that has value for users and that it can ideally give to users to receive feedback. You can think of sort of the first increment being like the MVP maybe, or maybe like you need 2 or 3 increments to get to like something that you can release as a public MVP, and then sort of every 6-week increment sort of improves that, adds a new feature set and so on. And that makes the scope that you're dealing with much smaller, and you can plan and prepare that at an intermediate level of detail with relative confidence. And then the individual work items are the smaller scopes you're dealing with. It's usually like only like a day or a few days worth of work maybe. And here you go into as much detail as you can. And that's what many teams don't do. Like you really, before starting to work on something, you want to uncover like all of the uncertainties and any potential risks and challenges up front so that you really understand what you will do before doing it to prevent running into problems then. And the next pillar I want to mention relatively briefly only is process and collaboration. The projects that we all work on are team efforts, of course. So the practices and processes around communication and collaboration among the team are essential for a project's success. And only teams that work together well will be able to achieve the best results. All project teams have a number of members with different priorities, different perspectives, and so on. Like you have the product expert, the salesperson, the engineers, the marketers, the designers, the accountant, and so on. However, many projects are really driven mostly by one of these team members only, or for the most part. If you're doing Scrum, for example, that even sort of demands that, right? When it says that the user's perspective is the only thing that counts. And while that makes sense in theory, in reality, this usually leads to product managers dictating priorities, focusing on delivering features fast, which results in building a debt on all other fronts and degrading all other team members to mere executors of the PM's plan. Like you cannot pretend when building software that like the end user's perspective is the only thing that matters. Like you're still dealing with something that is it's made of code. It has like sort of design needs to be considered beyond of sort of what the user might tell you they want. You cannot negate all that. It sounds good in theory, but it doesn't work. So we are advising against that, and instead for truly self-organized teams with no dedicated management role or no single contributor dictating everything, dictating direction and so on. Instead, you want to have direct communication and collaboration between all team members because that fosters appreciation for each other's perspectives. It ensures all team members' motivations and needs are considered, so you prevent sort of building a debt or focusing focusing on debt too much and neglecting features and so on. And it results in a feeling of shared ownership for the project among the team, which is critically important for long-term team motivation. And of course, this communication and collaboration won't look like this, right? People in a meeting room with Post-its on the wall. Admittedly, nothing says we're modern, we're agile, we have a bit of the startup vibe more than this picture. But while this is great for marketing brochures or landing pages, maybe, it is not a reasonable approach to running software projects anymore, of course. In the year of the pandemic, it seems unnecessary to say, but the days of the office at least for teams that build digital products, are over. They were over before the coronavirus and are definitely over now. People are happier, more focused, and more productive when they get to choose where they work, and forcing everyone to work from the same office is just a competitive disadvantage. And it will be even more so after the pandemic, when people don't want to go back to old working styles, right? After they have seen how well things work remotely. Our company, Simple Labs, has been full remote since we were founded, and so have many of our clients and like many other successful companies, right? So this is an image showing the past, right? The future is people being anywhere and everything being in cloud-based tools. But this is not about sort of going remote, but about the three pillars. So we have talked about planning preparation. We have talked briefly about process and collaboration. So now I want to go to the third pillar, the one we'll be focusing on in this talk, which is infrastructure and practices. Teams need to be given the right tools to deliver the best work in the most effective way. And the goal must be to provide them with a highly integrated and automated system that allows them to deliver like a steady stream of value. Elon Musk refers to Tesla's gigafactories as the machines that build the machines. And this works the same way for software projects. You need a well-running machine, a proper factory to build the software. And that doesn't mean you eliminate all humans and the software like sort of writes itself, but the factory that the team operates allows them to excel. However, in our experience, as I said before, this is very often overlooked. We see many teams operating like in mediocre environments, fighting these environments rather than being supported by them. And of course, the infrastructure and practices you need for software teams doesn't look like the factory on the slide here. When building cars, you're dealing with steel and so on, while we are eventually dealing with source code. That's basically what we transform, like everything that sort of is created before the source code is written into eventually, right? That's sort of the currency, the matter that like our products are made of. Yeah, we're talking about digital product development here, and you'll end up with a lot of code, and usually several people contributing to that code base. So the question is, what are the practices and the infrastructure that enable teams to efficiently evolve code bases over time as projects progress? And I don't want to go into technical details here, just like give more sort of a high-level overview sort of for how an efficient pipeline would look. Of course, the most essential thing that you need is version control, but it's also not just it's not just about setting up a Git repository or like having an account on GitHub and then sort of like pointing developers at that. It's also about like applying the proper strategies when using that. And by that, I mean, first and foremost, evolving code bases in small isolated steps following a single strategy. And don't worry, I'm not going to dive deep into technical details and give an engineering talk. The idea here is that you start with a main branch and create a feature branch based on that for the work item you're working on. That's basically sort of the feature branch pull request workflow that was established basically by GitHub like years ago already. And the changes in those feature branches are then reviewed, tested, and so on, which might also lead to subsequent changes. Like you have like a bit of iterative thing going on there. And we'll talk about testing more later, but the manual review by a peer is essential as well here. This is for two reasons. First, quality assurance. Everyone makes mistakes, becomes sloppy under pressure, and so on. And while most problems should be detected by test, you'll never find everything like that. A second pair of eyes is essential to ensure high quality. And here we're talking mainly about like, aspects of quality other than sort of functional correctness, other than whether something works as expected. It's more about like, maintainability. Will like my teammates be able to understand and change that code? Will I be able to understand and change that code in the future, and so on. And the second aspect why reviews are critical is for know-how sharing. The worst case scenario is you have a code base or parts of a code base that is only understood by one engineer, and then that engineer leaves the company or like gets the coronavirus or whatever. Nobody else is left who knows that code, and like nobody will be able to make any changes. And this, it sounds like something that's a bit like hypothetical and doesn't happen in reality, but I've seen it happen over and over and over again, where like companies did not have a peer review process, or people were sort of overly defensive about their part of the code base, which is also like bad, of course. So once reviews and tests pass, the changes merge back. And there are three essential points to this approach here. The branch is kept small and focused around one thing only. It gets a small unit of work. Quality and correctness is ensured before the branch is merged back and not afterwards. And there's only the master branch and the feature branch, and that's all. Many teams apply like very sophisticated and complex strategies involving like several branches and rules when which branch can be merged in which other branch and so on. But I have never seen those work in reality. Like people get confused, like people accidentally merge like between the wrong branches or whatever, and then sort of your process doesn't work anymore. In reality, simplicity is the only thing that leads to long-term success, and it doesn't get simpler than like main branch and feature branch. And of course, collaborating on code is only made possible with a code collaboration platform. Really, that's like why you use GitHub, GitLab, and so on. That's pretty much widely understood now. That is how we work with code, but there's also other kinds of sources, of course, which are design sources. And while there's only one kind of code read, there's two different kinds of design sources. First, you have exploratory design, which is used for like visualizing concepts and brainstorming ideas in meetings. And these design sources are more like one-off in nature and used to guide communications or discussions or enable decisions. They are usually not evolved so much over time, really. So there's relatively little long-term collaboration happening around these. What's maintained and evolved over time is like what I would call the definitive design, which is concrete and detailed UI design for an application, screens and elements. That kind of design should be organized and evolved as a collection of reusable components usually. And those components then are assembled into larger components and screens of the application, so that as more of the UI is developed, the bigger the component library will grow, and the more the UI will be based on components in it, which reduces the work needed for every new part of the UI and ensures consistency across the application. The end goal here is to eventually create a design system, which is a set of interconnected patterns and shared practices that serve the purpose of a digital product. In that sense, it goes beyond of what, for example, a component library does, and also takes things like icons, colors, typography, and so on into account as well. It's also more valuable than having individual designs for each screen of the application that are done independently of each other over time. And every time there's a new screen, since the design system builds on reusable components, so that new screens will be constructed based on those. And essentially, that's how we've written software for quite some time, by extracting individual reusable modules in the source code and then reusing those when we build new screens and features. And design systems bring that same approach to design, basically. And there's more to learn for design from engineering. We can also apply the same workflow that we talked about for source code. And just as we evolve a code base, one small isolated change set at a time, we can do the same thing for design sources, starting with a central authoritative mainline again, and creating an isolated change set based on that, which is then reviewed and merged back. And the benefits are the same as for working on source code. And while you can use the same version control system you're using for an application source code, there's a few specialized systems that make that a bit nicer for design sources as well. Obviously, an important part in both of these workflows is the testing step that happens before something is being merged back. In any software project, the only way to ensure what you do actually works is to test. And if you don't test, you will not know what you did works or not. And thus you will have to assume it doesn't. Although testing is of the absolute essence, it is surprising how often it is not done properly or not at all, which leads to the same problems every single time, degrading quality and teams lacking the confidence to move at an even intermediate pace, right? It always seems like skipping tests makes you faster, but that's only for like a very short period of time, like maybe for a few days. Okay, it works like that, right? Skipping tests will slow you down, not only eventually, but like very soon. And it's not just important to test though, it's also important to do it right, which mainly means three things. Manual testing is essentially the same as node testing. Of course, you can click through things, even following elaborate testing protocols, but manual testing is slow, expensive, and unreliable. It can be an addition to automated testing, but never a replacement. So automated testing is an absolute must. In fact, we don't work on projects that don't have automated tests or where we cannot add them in case they're missing. Second, tests need to run for every change and give immediate feedback. That is what CI means, like continuous integration. Someone makes a change to the code in Git, a test run is triggered on the CI server automatically, and immediate feedback is given to the author of the respective change, so they know what change broke which tests and can act on that right away. And last, functional correctness is only one aspect. An app can work correctly but still be visually broken. And you want to test for these things as well. There's great tools for functional regression testing available. Not everything can be tested automatically though. We said automation is king, but sometimes it doesn't work. Some things require sort of manual approval from other stakeholders. For example, to ensure there was no misunderstanding about how a particular feature was supposed to work. And that approval, of course, should happen before the respective change is merged back and becomes part of your main branch. And that kind of approval workflow is enabled by previous system. The previous system allows changes to an application to be shared with other stakeholders before the respective branches merge back in version control. It is a system that is spun up on demand based on the respective branch so that other stakeholders can access it and interact with it just like the real system. And that way they can preview changes and approve them or ask for additional modifications before those changes are applied back. Because once any change is applied back, like merged back, what you want to happen is that change being released to production automatically and immediately. In the past, releasing updates to applications was a bigger task. People would have release dates where everyone was rushing to get their work in until the deadline. And then there were huge releases, often with dozens or hundreds of changes at the same time. And when something broke, nobody had any idea what particular one of those changes caused the problem. And these setups mainly exist for a lack of automation around development, testing, previewing, and releasing. The infrastructure I'm describing here was very hard to set up only a few years ago. That is not the case anymore. Nobody should be doing huge scheduled releases anymore. You want to release a steady stream of lots of small changes, all tested and approved and automatically released like this. However, there's one important thing left. The best testing setup will only be able to prove things work on the test system, but production can be different. Users behave in weird ways, external dependencies are out of your control, and so on. So just assuming everything in fact works as intended or as tested in production is risky. And not a risk you want to take usually, as you're potentially paying users who run into these bugs then. You need to know things work in production. So there's three essential things to do. If errors occur in production, you need to be aware. There's nothing worse than learning your system is broken through your users when they tell you. Ideally, you want to know there's a problem and fix it before they even realize. So a tracking or reporting tool that makes the development team aware of errors is absolutely critical. Also, no errors being reported in that tool can also be because nobody is using a particular part of the system you have built. Understanding whether or how people use the system is critical for understanding whether what you build is even relevant to them, of course. So you need to analyze users' behaviors, which, by the way, doesn't necessarily mean giving up on privacy and spying on everyone's private data. There's plenty of way to do that in non-invasive ways, like fully GDPR compliant and so on. Last, releasing everything right away does also not mean it needs to be released to all of your users all at once. Sometimes you might not be sure whether users like a functional or visual change. So you can roll it out to part of the users only and see how they react, like doing an A/B test, right? Sometimes you might also not be sure whether the system can handle the load of a new feature. So you can roll out the feature incrementally to like rolling share of your users and keep an eye on the service along the way, like using feature flag mechanisms and rolling releases and so on. And now, with all of these practices and infrastructure that we talked about in place, you'll reach the ultimate goal that all digital product development teams must aim for. And that is a highly integrated and highly automated pipeline that allows the team to consistently and sustainably deliver a steady stream of value. It starts with a work item from the iteration, from the team's current iteration. And that work item has been well prepared and is very unlikely to lead to any unforeseen challenges or blockers, as explained briefly earlier, right? Where when you like prepare work on sort of the small scale of an individual work item, you want to make sure understand at a detailed level what changes you will be making to the application sort of to complete the work item. Then the next step is the designer makes the necessary design changes in a branch. And in that branch, they link to the work item, of course, and the work item links back to their branch. So you have like all of the context that you need at either side of this process at all times. The changes are then reviewed and merged back, and the engineer makes the necessary code changes in a branch as well, which is also interlinked with the respective work item, of course, and probably also the respective design change there. And the changes are automatically tested and potentially manually approved by other stakeholders on a previous system. And then once the changes are merged back, the status of the respective work item, of course, and the work item tracking system is updated automatically, and the changes are auto-released to the production system. And the production systems then observe constantly for any problems that might still be occurring there. And that's the same for every task. And of course, teams will be pushing multiple tasks through this pipeline in parallel at any time. And this kind of pipeline enables teams to constantly, consistently, and sustainably deliver a steady stream of product value to a company's users with confidence and minimized overhead. And I want to repeat this to be entirely clear. This is not something that developers or designers would want to have the same way they would want to have like stand-up desks or nicer chairs. Any digital product development team that is not supported by pipeline like this is not operating at their full capacity and will not be able to deliver the same product value to a company's users for the time and money invested as a team that is supported by such a pipeline. And that is all I have. Thanks. I'll be around to answer questions, of course. Thanks for having me.